So a telephone company wants to run a cable from a point A on one bank of a river to a point B on the opposite bank and 12 kilometers downstream from point A. The river is 5 kilometers wide. The company can run the cable along the shore at a cost of $1,000 per kilometer and across the river at a cost of $2,000 per kilometer. What lengths of cable should be run along the shore and under the water to minimize the cost? So let's quickly draw a diagram to visualize this scenario. Okay, so here's a diagram, and this diagram shows us there's 3 different ways you can travel across the river to the point B from point A. So basically, you can go across to point C, so A to C, then C to B. This is the longest distance the cable can run through. That means it'll cost a lot as well. And then there's another option. You can just go straight from point A to point B, but the problem is you're going across the river like for the entire trip, and going across the river costs $2,000 per kilometer. So that's also very expensive. And the third option is the red lines, which I made with the red, and those just show that it might be more optimal to travel from point A across the river a certain distance, and then from that point just go to point B, and then I will label that point as X. So basically this distance over here is all X, and this X will help us do a lot of things. So first it will help us find this distance, which I will call dW. So dW is this first red line that goes across the river diagonally. So dW, we can just set it equal to the Pythagorean theorem, where it's 5 squared plus x squared. Because you see how this 90-degree angle is created? So it's equal to 25 plus x squared. Then dl is basically just 12 minus the x. As you can see, x covers this amount of distance, and then the rest is covered by walking. So the distance on land is 12 minus x. So with these two in mind, we can put them in the cost function that we will create. So we know that it costs $2,000 per kilometer in water, and it's $1,000 per kilometer on land. So this is a simplified version of the cost function. Now we will find the derivative of the cost function and then set that equal to 0 to find the critical points of x. So x is equal to 2.8. This is the critical point. And now with this, let's find the distance where basically this is the point where the cost is the lowest. And let's use this to find the distance traveled on land and the distance. So by plugging in the x as equals 2.886, I got this value for water. The distance should be traveled in water, and this for the distance traveled in land.